This Autodesk Fusion tutorial will show you how to take an STL file from another project that you have or from something that somebody's made and is released on a maker site. This is a question I often get on how to change a mesh into a parametric CAD model. There are, of course, commercial ways to do this in Autodesk Fusion with the Prismatic option, but that's not available on the hobby license. And even with that option, you still have to do a lot of manual reverse engineering. So this is going to take a simple STL file from MakerWorld and then reverse engineer it into a parametric CAD file inside Autodesk Fusion. I do want to note before you just go to MakerWorld or Printables or Thingiverse and grab things that say they are open source or Creative Commons. That's not always true. For example, here on Printables, you can see this cool door shower wall hook. Down at the bottom, the model origin says the author marked this model as their own creation and it's Creative Commons. You might think, great, now I can download this and do my own commercial things with it. But you should be really careful. There's a couple things that might clue you in. This is a very recent model. Also, these are quite professional pictures. I'm not suggesting that this user couldn't take professional pictures, but did they go through the trouble to print 3 different versions of this? Or is this a picture from something else? A quick reverse image search will bring you to another page from another user who has more followers and has been more involved in the community. I'm not sure who is correct, but I believe that this person is probably the one who created the original model. And user Yetka has not made it as an open source model. So be very careful. You don't want to get yourself in trouble. For the demo, I have this model, which is clearly marked as public domain. It is made by user Vanecki4. It's a lamp adapter for an organic ripple lamp. The reason I chose this is because it appears to be the user's original creation. It's marked as public domain. I'm working with my students with lamps right now, so it's very relevant. And I think it's a simple enough design that even if this was a commercial design, it is not novel enough and we could reverse engineer it on our own. I want to thank Vanecki for this cool design, and we're going to download the STL file and show how to reverse engineer it. In Fusion, make sure you're working in hybrid design. Then click the Insert Mesh. Navigate to where the mesh is inside your computer and click Open. This brings the STL file in, and we can basically leave it where it is. We could work with it as is, but it's a little hard to use the mesh just like this. So select Mesh Workspace, then select Generate Face Groups. If I select this mesh and I click OK, it'll do its best job to generate face groups and see which parts are going to be there. This would be great if we had access to the Prismatic converter, but we don't. We're going to manually model this mesh. Click Modify, Convert Mesh, select the mesh, and make sure you select Parametric or Base Feature. We're going to use Parametric because that is available on all the licenses. And this is now a body, and we can make modifications to it. But it's not a very useful body because it has all these facets on it. So how can we quickly reverse engineer this? Back in the solid workspace, right-click, make a new component. Call it New Lamp Base. Now inside this new component, select Construct, Plane through 3 points. Orbit to the bottom of the lamp. We're going to click 3 points on this base. And I want to get one way over here. I'm sure this was modeled in CAD and this should be perfectly flat, but you never know. So now I have 3 points. Press OK. Create a sketch right on that new plane. Press P to project, and we're going to do the same thing. I'm going to project in 3 points from the outside of this circle. And while I'm here, I'm going to orbit so I can see this inner lip, and I can project in 3 points for this circle. Make sure they're spread apart because you don't know what mesh angles there are, and you don't know if it was a scanned mesh or anything like that. So now I have these 3 points. I can briefly hide the bodies of the lamp base original, and then if I select Create Circle, 3-point circle. Click the 3 inner circle points, then click the 3 outer circle points. Then we can finish our sketch. If I bring the body back, now I have a perfect circle on the bottom of this STL file. But I need to know how much to extrude. I could eyeball it, or I could accurately calculate where it needs to go to. So I'll go ahead and construct another plane through 3 points. This time I'm going to select points on the top of this lip. Make sure your points are spread out. This will give you the most accurate reading. Now I have my plane, and I can say OK. Next, I'll extrude, and the profile that I'm going to extrude is this bottom profile, and the distance will be to an object. I'll use the new construction plane as the object, and there I go. I now have a new body. So we've already reverse engineered part of this STL. And if I hide the original one, you can see this is a typical solid inside fusion. I'll hide that construction plane for now, and I'll bring back the original body. Now there's a couple ways we could go about this. We need to shell this, so we could do two extrudes. I think what I'll do is I'll create a plane at the top here because I need to get this hole. So first, construct plane through 3 points. And this time we'll select points that are on the top of this. So now I have a plane on the top. Press OK. I can create a sketch on the top here. Press P to project. I need 3 points for this inner circle hole here. And I also need points for the outside. So press P to project. And be careful not to select any points that are on the actual end of this fillet. So I want to go all the way to the edge. This is the wrong point. I want to make sure I pick on the edge. Then press OK. Now I'm going to hide the original STL file. We'll create a circle with 3 points. This will do the interior circle by clicking these 3 points. And then this will do the exterior circle. So now we have a sketch right where we need it to be. Now I'm going to go ahead and press E and extrude this down. And the distance will be to an object. And we'll go all the way down to this object. And that meets fine. And we'll press join OK. Now we need to extrude this inner part to shell it. But we need to know how high. Of course, it's probably exactly the same distance as here, but we don't know for sure. So I'm going to go ahead and hide the bodies, bring back the original STL file. Now we'll use one more plane through 3 points. Press OK. Then we can hide the STL body, bring back the original body that we're now making in Fusion. Press E. I can use this body plane or the sketch plane. The distance will be to an object. And then I can use that construction plane as the object. The operation will be cut, and you can see it goes straight down like that. If I bring back the original STL body, we can see that we need a fillet right here. I also believe that there may be a fillet on the inside. To confirm, we can use a section analysis. And if we look at this, the original STL body only has a fillet on the outside. You can also use this section to help more accurately guess where the fillet is. So I'll click fillet, click this outside edge, then I can bring this in manually. And most of the time people are going to use round numbers, so when you get to something close, and in this case, it sure looks like 2 millimeters is the magic number, you can press OK. I'll hide the analysis, hide the original STL. Now you have a solid model inside Autodesk Fusion, reverse engineered from an STL file. I do want to remind you though, be very careful when you're looking around for Creative Commons and open source licenses, because a lot of people are less than honest online. So you want to make sure that you're really using things. And even if it says no attribution necessary, it's always a good idea to give attribution when you can. And as a reminder, this model was by Vanek i4. They made this model. Looks like they printed it. Pretty cool lamp. Way to go, Vanek i4. Thanks for sharing with everybody. So hopefully you can use this to reverse engineer an STL file. I know this was a simple one, but these techniques can be used on more complex files. The same workflow. Happy 3D modeling.